Okay, so we've got here part of the surface of a small lake is covered by green algae. The area of the lake covered by the algae at time t years is a meter squared. And it says the rate of increase of a is directly proportional to root a. So a here is increasing, yeah? The area of the green algae is increasing over time. So when it talks about the rate of increase, okay, it's looking at the gradient function of it, remember, okay, how it's increasing over time. Yeah, when you see these words, rate of increase, rate of, it's looking at how a is changing over time. So we're going to be interested in the gradient of, if a was a curve, we're interested in the gradient of it. And of course the gradient is increasing, isn't it? So dA by dt, a over time, right, is increasing, so it's going to be positive, and it says it's proportional to root a. Okay, so to set up my differential equation in part A, we'll put this first. But of course, remember, with an equation, we need an equal sign, and to get that to an equals, we introduce a constant of proportionality, which of course we just call k, and we've got this. So then in part B then, notice they give us some information. They say, look, when t is 3, the area is 64, and when t is 5.5, the area is 196. Find an expression for a in terms of t. So we need to get a equals, yeah, that's what it means, a equals. So we need to integrate this, right, to get the function in terms of a. Here, remember, we've got the gradient function, okay, how a is increasing. So we can integrate. But to integrate, because we've got a's on both sides, yeah, we need to, of course, then separate the variables, okay. When we separate the variables, because we're timesing these here, we can take the root a over and divide. So it'll be dA by root a, and that will equal to k dt if we take the dt up. Of course, the purpose then is to integrate, okay, with respect to these variables. So we've got here, this time is square root of a on the bottom, so we're not going to have ln a like the previous questions, because it's square root of a here in the bottom. So the way we'd integrate this, of course, is we need to take this up first, yeah? So we've got square root of a, that will be a to the power half. So if we take it up, it'll be a to the power minus half, yeah? Okay, change the power to a negative. And then, of course, k then, dt, well, I could take the k outside of the integral, and I'd just be left with dt here, yeah? Or 1 dt, yeah? 1 in if you want. So when I integrate this then, remember C2 rules, you just add 1 to it. So we learned in C2, add 1 to that, so you get power half if you add 1, divide by the new power, and that will equal to then, well, 1, when you integrate it, you get t, don't you, with respect to t, so it'll be t and k in front, so kt, plus then a constant of integration when you integrate, because there's no limits here, so you've got to make sure that's in. And then when you've got this then, well, we can take that 2 up, okay, because it's half, flip the fraction, take the 2 up. Now, a to the power half, of course, is root a, isn't it? Square root of a, so I can write it like that, equals kt plus c. Okay, so to get an expression for a, all right, what we need is to appreciate that we can work out now what these values of k and c are, yeah, to get an expression of a. Because if you look at the question, it says find an expression for a in terms of t, okay, a in terms of t. It doesn't want k and c involved. So we need to, quite simply, use the conditions that they've given us. So let's look at the conditions. T is 3, a is 64. Okay, when t is 3, a is 64. So if I put that into here, I'll have 2 root, what have we got? 2 root a, so there'll be 2 root a is 64. Okay, and that will equal to kt. K times 3, because t is 3, plus c. So I can work out there, what have I got here? 2 root 64, was root 64 is 8, so that'll be 2 times 8, which is 16, that'll be 3k plus c. So I've got an equation there, alright, and then I've got another condition. It says when t is 5.5, a is 196, that's what it says in the question. So if we sub that in here, I'll have 2 root 196 equals to k times 5.5 plus c, okay. Now, root 196 is 14, you can use a calculator, so then 2 times 14 is 28, 5.5k plus c. So, notice now we've got two equations, two simultaneous equations, and I can perhaps line them up. So, I've got them like this. And we can simply use that then to work out what k and c are. Yes, if I call this 1 and 2, and what I perhaps will do is, because you've got c's the same here, I'll just do 2 take away 1. Okay, so if I do 2 take away 1, 28 take away 16 is 12. 5.5k take away 3k is 2.5k. And then, of course, c take away c is just 0. So that implies then that k will be 12 divided by 2.5. If I work that out on my calculator, I get 24 over 5, or 4.8. Okay, so we've got k, so we just sub it back in into say number 1, sub into 1, to work out what c is. So we've got 16 equals to 3 times 4.8 plus c. So then c will equal to 16 take away 3 times 4.8. So I get c to be 8 over 5, which is 1.6. So now putting it back in here, I'll get 2 root a equals to kt, well k is 4.8, so that'll be 4.8t, plus c, which is 1.6. Okay. Now remember, I want an expression for a in terms of t. So what I do is, because there's a 2 there, that's a bit annoying, so if I divide through by 2, so I'll get root a equals 2. Well, if I divide that by 2, I get 2.4t. And if I divide that by 2, I get 0.8, yeah? And then, to get a in terms of t, well, that's root a. So what I need to do is, I need to take that square root over the other side and square that side. So square the whole thing. Okay, so we get that squared, and we've got an expression for a in terms of t.